In this video, we're going to integrate some basic integrals using some of the first formulas you get when you start working with integrations like this. Sometimes they don't include this k, which represents a constant. So we have the integral of k and say x to the n dx. Take the integral of this, you add 1 to the exponent there, you get x to the n plus 1, and you divide whatever coefficient you have here by that value. You get n plus 1. And then of course you have your constant of integration. Always have to have a constant when you take an antiderivative of an indefinite integral, because the derivative of a constant is always 0. So you could always have a constant after you integrate. Notice when you go the other way, take the derivative, it's n plus 1 times the coefficient, the n plus 1 cancels out, then you subtract 1, and it gives you the original. Now the condition here, of course, is that n cannot equal to negative 1. Because negative 1 and 1 is 0, that's undefined. So when you have x to the negative 1, or let's just call it 1 over x instead of x to the negative 1, you have a special formula for that case, and that's the natural log of absolute x plus the constant of integration. So for the most part, these are the formulas that we'll be using. So this particular video is those of you that are just beginning to evaluate integrals in first part or early part of probably calculus 2. You get it in calculus 1 also, and some students will start at the last part of calculus 1. They introduce you to integration. So for this one here, here's the way it's going to work. It's always nice to have x to a power. So if we can get the x out of the denominator, we like to do that. So in this one, I'm going to have 2/3. I'm going to write this as 2/3. This is the integral here. So this is going to be the integral of 2/3. I'm going to bring the cube root of x to the numerator. Remember, cube root of x is the same thing as x to the 1/3. So if I go take it to the numerator, I write it as x to the negative 1/3 dx. Easier to integrate if you have it in that form. And then we just follow the power rule for integration. We add 1 to the negative 1/3. So it's 1 and negative 1/3. This is going to be 2/3. And then you divide the coefficient, which is 2/3, by that value we got. So this is going to be 2/3 divided by 2/3. That's going to cancel, plus the constant of integration. And then continue with the simplification, because this cancels out. So I get x to the 2/3 plus the constant of integration. So notice you can also check your answer on these by just computing the derivative. So if you take the derivative of this expression here, the derivative of a constant, c represents a number. So that's one of the formulas. If you have the derivative of any constant, 2, 3, I just call it c, that's going to be 0. That's why we always include a constant when you integrate, unless you're evaluating a definite integral where you have limits of integration. There you don't need the constant, because the constant eventually cancels when you do the subtraction. But notice here, if I multiply, take the derivative, you do the opposite of the power rule for integrals. The 2/3 multiplies the coefficient here. I get 2/3 there, and I subtract 1 from this. I get 1/3. That gives me the cube root. Take it to the denominator, and it comes out x to the 1/3, which of course is cube root of x. So there you have it. And so this is your answer for that one. Now, the next one, again, you have a trinomial here. It's already simplified, so we just follow the rule for integrating a monomial term. We add 1 to the exponent, so it's 2 and 1 gives me a 3. And then you divide the coefficient by 3. That's the formula we just went over. Power rule for integrals gives me 2/3. Then for the next one, exponent is considered to be a 1. So we add 1 to that, we get 2. And the coefficient is considered to be a 1. Divide 1 by 2, we get 1/2. And then the next one we got is, so you can think of this as x to the 0. It's a constant. So you can think of that as x to the 0. So if you add 1 to the 0, you get 1. That gives you an x. So this is just minus 1x or minus x. Plus a constant of integration. So anytime you have a constant, say c, and you're integrating, there's no x there. Think of that as x to the 0. That's just give you cx. And I'm using a c here. I'll use something else for, well, I use c1 with a constant of integration. So for this one, it's 2/3 x to the 3rd plus 1/2 x squared minus x plus the constant. Now for this one here, and the next one, number 3, we have 1 plus x to the 2nd. See, we'd like to have it in this form. You don't always have to have it this way, but it's convenient. Now this one we have it squared. So what we could do here equals here, and let's just square it. 1 plus x squared, a little bit of algebra, gives me 1 plus 2x plus x squared. Get a dx. And again, I can't integrate it this way, the way it is, because I have something in the denominator, so I have to simplify this. So square root of x is the same thing as x to the 1/2. So you don't want to do this and say, okay, 1 is a constant, so that's just x, and over here 2x, add 1 there, and you get x to the 2nd, and then 2 divided by 2 is 1. You can't do that. Here, we have to divide this out. So term by term, we go ahead and divide this out. So it's going to be 1 over x to the 1/2. I'm just going to write that as x to the negative 1/2 plus, and then 2x over x to the 1/2. So the 2 is already in the numerator, and then this is a 1 here. So it's 1, subtract the exponent, so it's 2x to the 1/2 plus, and then again I have x squared over x, just basic algebra, x squared over x to the 1/2 here. Subtract the exponents, bring the x down, subtract the exponents, so it's 2 minus 1/2. Here's 3/2. Now this one is kind of like number 2, except it's not a polynomial because the exponents are fractions or negative. But it's still, you can still use the same property. So what we do here, we have x to the negative 1/2, so we add 1 to the negative 1/2, we get 1/2. And then we divide the coefficient by 1/2, so this is 1 divided by 1/2, it's going to be 2. And we have a plus here. Then we have x, add 1 to the 1/2 here is 3/2. And then you divide the coefficient by 3/2, so you invert and multiply then. So it'll be 2/3 times 2 would be 4/3. And we continue then. Then next to the 3/2, we add 1 to the exponent, so it's 3/2 plus 1 is 5/2. And then we divide the coefficient, which in this case is 1, by 5/2. We're just inverting and multiplying. So it'll be 3/5 or 2/5. So we get 2x to the 1/2, 4/3 to the 3/2 plus 2/5. And then go back again. 2x to the 1/2 plus 4/3 x to the 3/2 plus 2/5 x to the 5/2 plus a constant of integration. You always going to have a constant of integration when you compute or evaluate an indefinite integral. If you got a definite integral, say that has limits from 1 to 5 or 0 to 2, there you don't have constants of integration. This is the answer for this one. We'll clear this. Now if you look at this one here, just like in algebra, you change the variable. You have a quadratic equation and you rewrite it in terms of another variable, y, and then you solve that equation for y, and then you go back to the original variable to find the actual value of x. Well, here we do the same sort of thing. Because see, this is the square root, but it's not like just the square root of x. It's the square root of 2x minus 1. To make it easier, what we do, you do this a lot when you get into more advanced problems, and I've done some of those on this channel. Right now I'm going back to basics if you want some of the easier integrals. So what I'm going to do here is let u equal to 2x minus 1. So I'm going to rewrite it in terms of another variable. And then I'm going to say, okay, that means that using the differential, what I'm doing is taking the derivative here, du, derivative of 2x minus 1 will equal to derivative of 2x is 2, derivative of negative 1, that's a constant. Derivative of a constant is always 0. So this is just going to give me 2, and then the dx. And then I say, okay, let's rewrite this integral here in terms of this new variable. So instead of the variable x, we want the variable u. So what do we have here? The integral, got the integral. The integral of the square root of 2x minus 1. Okay, so it'll be the square root of 2x minus 1. But 2x minus 1 is u, so I'm going to put a u here. Now here, I want just the variable u. This is dx, so let's solve this for d. Let's divide here by 2. This by 2. This cancels out. So in place of dx, I'm going to use dx is equal to du over 2. I'm going to put du over 2. And I'm just going to write that 1/2 in front. Anytime you have a constant, that's just a number, you can always bring it out here. Now this one here is kind of like over here when you have a radical. So let's just do this. This is equal to 1/2 the integral of u to the 1/2 du. Now I can integrate using the general power rule here for integrals. This will be 1/2. Add 1 to the 1/2 here. We'll integrate now with respect to u instead of dx or x. So add 1 to the 1/2, I get 3/2. And then I divide the coefficient, which in this case is 1/2, by 3/2, which means I just inverted multiply, so this would be that, and then it's plus the constant of integration. Notice the 2 here and the 2 here cancels, and this will be 1/3 then out in front, and then the u, then you go back to the original variable. So u, we set it equal to 2x minus 1, so this will be 2x minus 1, and then the exponent is 3/2. So this then should be your answer. Also a note here that you can check your answer when you finish your integration, and you're supposed to get the original answer. Now sometimes it's pretty straightforward. Sometimes in order to verify you have to do a little bit of simplification because you get a different look of the answer. This one is pretty straightforward because, okay, we take the derivative of the answer, we're supposed to get this integrand right here. So let's see, 3/2 times 1/3, the 3 cancels out, that leaves me with a 1/2, and then we subtract 1 from the exponent, that gives me a 1/2. Okay, so far I got 2 square root of 2x minus 1, but I got a 1/2 out in front. Well, the last thing you need to do here to make sure it checks is using the chain rule, multiply by the derivative of what you have here, 2x minus 1. It's going to give you a 2. So that's going to cancel the 1/2. And it's gonna check. Thanks for watching. We'll see you next time.